What's up, guys? So this is going to be for Lab 5 today. We're going to be going over related and independent t-tests. For this lab, I'm going to show you how to do question 2, which is going to be a related sample t-test. Excuse me. And then I'll show you how to do question 4 here. And this is going to be a related samples t-test. Or I'm sorry, an independent sample t-test. So let's hop into it. So a major university would like to improve its tarnished image following a large on-campus scandal. Its marketing department develops a short television commercial and tests it out on a sample of 6 participants. People's attitudes about the company are measured with a short questionnaire, both before and after viewing the commercial. So was there a difference? And we see our alpha here is 0.05. And yeah, you've got your table right here. So this should give you a key about what we're doing right now. If we're asking if there's a difference, we're not really suggesting that there's going to be a hypothesized direction in this relationship. So this is going to be a two-tailed test. It's looking like with a 0.05 alpha level. So let's go ahead and go to Jamovi and show you guys how to do this. I already have my data in an Excel spreadsheet, so um, you can enter it straight into Jamovi. You can't talk and do things at the same time, apparently. You can type this directly into Jamovi. You can use an Excel spreadsheet, however you prefer. Uh, so we've got this is over here, right? And then we're doing a related sample t-test. So these are the same people. A is the same person, B is the same person, C is the same person, and so on. And then they got their scores before viewing the commercial and then after viewing the commercial. So super easy. When we want to do the t-test, we are going to do, I believe, a related sample t-test, excuse me. And then we're just going to go ahead and throw these paired variables in. Let's go ahead and check for the mean difference and confidence intervals. You can see here for the hypothesis, measure 1 is not equal to measure 2. This is going to be bidirectional, so again, like we're just trying to see if there's a difference between before viewing the commercial and after viewing the commercial. So we're not predicting a direction in this relationship. So let's also go ahead and check off descriptives because we'll need that for our response. And if you want to get fancy, you can check out normality um, and even the QQ plot if you really wanted to see how like the data maps onto a graph. But so we can see here, this is the t-statistic, the degrees of freedom, and our p-value is 0.137. So that's telling me it's not significant. And then the mean difference between before and after viewing the commercial was negative 2.17, but for the purposes of this assignment, you don't really need that. You just kind of need the descriptives down here because once we say the results, um, let's just have these side by side here and go through. So we did a two-tailed test, right? There was no hypothesized direction. We ran a related sample t-test, and we tested if there was a significant difference between before and after viewing the commercial, right? And then the average score before viewing the commercial, the mean was 11.83, and the standard deviation was 2.14. We obviously took that from down here, 11.8, and 2.14 for the standard deviation. Don't worry if there's no like 11.83 here. This is from R, so it gave me an extra decimal point, but 11.8 is also very acceptable. And then this standard deviation is necessary because we need to see, like we need a measure of dispersion um, with this mean here, because the mean alone doesn't really tell us very much. And so let's start over. The average score of before viewing the commercial, mean and standard deviation of before, is not significantly lower than that of viewing the commercial after. This should actually be not significantly different than after viewing the commercial. And same thing here, with the mean is 14, standard deviation is 2.9, and now we're going to write the equation that we can get from up here. So t with 5 degrees of freedom equals negative 0.178. And we got that from this statistic right here. Don't worry if you did negative 1.77, that's also fine. And then p is greater than 0.05. We can obviously see that from our p-value right here. So super easy. And this shows that there was no significant difference between between before and after viewing the commercial. So very straightforward. This paragraph is going to be like a really great formula that you can use for any subsequent problems that ask you to respond in APA format. So let's go to question 4, a little bit different. This is going to be an independent sample t-test. So suppose that there were two brands of gasoline that were being compared for mileage. Samples of each brand were identified, and then under identical conditions, and then 9 tests were made of brand 1, and then 6 tests of brand 2. So are these significantly different from one another? Again, this is an independent sample t-test. So the graph that you see here, once you enter your data into your Excel spreadsheet, or if you enter it into Jamovi, is going to look a bit different. Oops. Okay, so we have to have a line for each brand. So what I've done here, so this is pretty straightforward. Like I put the car number, so within each brand, there's a car being surveyed or measured, and then you have to put the brand name here, so it identifies as brand 1 or 2, and then their mileage. Because you'll see in a second why. It's because we need, just go straight to it. Oops. You're going to need some sort of a grouping variable. And if you were to just enter this in as is, Jamovi wouldn't know that you intend to group these variables. So the grouping variable that I've used is brand of gasoline, as you can see here. Brand of gasoline, brand 1 or brand 2. And then, oh, what's going on here? And then the dependent variable was mileage, not car number, because car number would be similar to the ID of the participant. So let's go ahead and check off the same things. Again, actually really quickly before we do that, this is really, really important. This is probably the first thing you should be looking at for the hypothesis. You need to make sure, otherwise your result, everything else is going to be off if this is wrong. So you need to make sure that the hypothesis is commensurate with what the question is asking you. And this question is not asking you a directional question. It's asking you whether they're significantly different from one another. So they're not equal to each other. So that's why we've checked this one off again. Let's go ahead and get the mean difference and our good old-fashioned descriptives. And then we read it the same exact way. So let's look here. This is our statistic, so it's 2.98. Our degrees of freedom here are 13. The p-value is 0.011, so not quite below 0.01, but it's below 0.05, so we've got some significance there. And then we have our group descriptives here, which we will need for our APA formatted answer. So notice that there are two, like the numbers in each group are different, and yet we're still able to compare them. Like the reason why this is so cool is if you just very quickly, like you see this p-value right here, it's not significant. So this means the homogeneity of variances, the variance of each sample is equal, is equivalent. For this test of normality here, they're normal distributions, so they're not like skewed in one direction or another. And we can see that with the Shapiro-Wilk here, it's 0.447. So it's just something kind of fun if you were curious about it. Uh, but let's go ahead and remove that so this makes sense. Um, Again, we conducted a two-tailed independent sample, two-tailed test, but this one was an independent sample t-test, and then we wanted to see if the two brands differed significantly from one another. So again, the average score of brand one, we got the mean, we got the standard deviation here, is significantly different from brand two, right? And then again, we've gone to the table, the group descriptives here, and then we've got the mean and the standard deviation for brand two. And then we have to say whether it was significant or not. So we have to include our t statistics. So t and then 13 degrees of freedom. And then we have our t value is less than 0.05. And then that means that there's going to be a significant difference between the two less than 0.05. So that's it. Make sure you have this formula here down for your APA style answer. And then, excuse me, make sure you export into a PDF document here and then upload that along with your homework submission to Blackboard. So I will see you guys in class. Let me know if you have any questions.